My name is Simon Foster, and this is a condensed geologic history of Yellowstone and Grand Teton National Parks. I've included this photo of Grand Prismatic as it is one of Yellowstone's most famous geologic features. Yellowstone and Grand Teton National Parks are located within 10 miles of one another in the Upper Colorado Basin Service Region. Yellowstone National Park, established in 1872, is the first established national park after decades of European American exploration. These explorers fell in love with the beauty of Yellowstone and decided it should be protected, especially as the idea of public parks were gaining in popularity. Grand Teton National Park was established in 1929. Railroads had brought not only tourists to Yellowstone, but also settlers to Jackson, Wyoming. Preserving the beauty of the American West remained central to the establishment of the national parks, and thus it became of urgent concern to extend the borders of Yellowstone to include the Teton Range. Grand Teton National Park was established instead. Here we can see a map of the national parks. Yellowstone and Grand Teton National Parks are circled in red. This map gives an overview of the greater Yellowstone ecosystem, which encompasses both Yellowstone and Grand Teton National Parks and the surrounding geography. Roughly 2.7 billion years ago, a continental plate collision led to the formation of the Teton's basement rocks, primarily metamorphosed gneiss from ancient seafloor sediments, which was cut through by magma that would cool into granite. Also visible on the Tetons are diabase dikes, which rose up roughly 775 million years ago when cracks formed in the crust as the region began to stretch north and south. Similarly, basement rocks in Yellowstone are largely gneiss and are found primarily in Lamar Canyon and Garnet Hill. Fossils dated back as far as 540 million years ago in both Yellowstone and Grand Teton indicate that the region was once an ancient seafloor. Some of these fossils include corals, algae, brachiopods, and trilobites. As the region reached the Cenozoic, it began to experience the majority of its development as a result of increased faulting and volcanic activity. Roughly 50 million years ago, volcanic activity unrelated to the Yellowstone hotspot formed the Absaroka Range, one of the most prominent mountain ranges within the boundaries of the park. This range, as well as others, were later shaped by tectonic stretching east to west 30 to 17 million years ago. This stretching resulted in the basin range topography that characterizes much of the region. The Yellowstone volcano is a hotspot volcano, meaning the North American plate moved over a magma chamber close enough to the surface to cause intense volcanic activity. The oldest evidence we have of this hotspot dates back 16.5 million years and can be found in Nevada. The position of the hotspot over time tells us the North American plate is moving roughly southwest, as can be seen in this map. About 10 million years ago, when Yellowstone's hotspot was under Idaho, north-south tectonic stretching would create fault lines that would merge to form the normal fault to begin the development of the Tetons. The geologic activity that created the parks as we know them today happened mostly within the last 2.5 million years. Yellowstone's first eruption in its current location occurred about 2.1 million years ago. This would have been one of the biggest eruptions we know about in Earth history. A second major eruption would follow about a million years later, and a third and final eruption occurred about 631,000 years ago, creating the current Yellowstone caldera, which can be seen along the Gibbon River and other parts of the park. Since the last major eruption, two magma domes have formed close beneath the surface, which inflate and subside, causing Yellowstone Lake to tilt and continuing to affect the park's topography. Glacial activity has also played a huge role in Yellowstone's geographic shaping. This map shows the glacial activity in the greater Yellowstone ecosystem over time. Evidence of glacial activity can be dated back as far as 1.3 million years ago, though the most recent glaciation 21,000 years ago has played the largest role in the geography of the park we know today. At that time, glaciers had formed a dam in Lamar Valley, which caused massive floods when they melted, heavily eroding the land, especially to the north. When Yellowstone stopped erupting, the region became ideal for flora, fauna, and eventually people. Evidence of human activity in the region from archaeological sites and oral history date back roughly 11,000 years. Archaeologists have uncovered teepee rings, fire pits, and stone tools in the Jackson Hole Valley. The area's resources made it the perfect location for hunting, fishing, and gathering for a number of tribes. Yellowstone's obsidian was ideal for tool making, such as knives and spearheads like these. While the summer was ideal, the winters in the area were harsh, so it was common for tribes to leave and return when it was warm again. Further, Yellowstone's hot springs were spiritually important for some tribes who used the sites for ceremonial and medicinal purposes. Some geologic features have even been named after prominent native figures. This photo reportedly shows Chief Tendoy, after whom Tendoy Falls are named. The Tetons continue to experience geologic change in the form of ongoing glacial activity and the continued movement of the Teton Fault. The Tetons have up to 11 active glaciers, many of which are visible from the surrounding highways. Both of these photos show a different perspective on the Middle Teton Glacier. These glaciers have played a huge role in the shaping of the Teton Range, and as they shift, they continue to shed tons of sediment into Jackson Hole and the Snake River. Since the establishment of both parks, the region's frequent forest fires have been of significant concern to park staff. While these fires appear destructive, they're actually a vital part of the ecosystem, and most of them are relatively small and contained. The fire of 1988, pictured at the top right, was one of the largest and most destructive in the park's history, caused by abnormally hot and dry conditions that year. Fires such as those are becoming more common as global temperatures increase and the area becomes hotter and drier. Over time, this could lead to climate conditions more similar to the American Southwest, which would be detrimental to the current ecosystem. The increasing temperatures are also causing other problems for the region. Glacial ice and yearly snowfall melt faster and earlier in the year, creating more runoff in the rivers, which could lead to the loss and/or relocation of a number of plant and animal species. Further, the earlier melt means a longer summer, which may end up affecting the migration patterns of nearly every animal that calls the region its home. Climate change could also be playing a role in recent bark beetle outbreaks, which wreak havoc on the forests, killing the trees and destroying habitats. While Yellowstone and Grand Teton National Park were established for their awe-inspiring beauty, they are so much more than that. They are the historical home of native people, plants, and animals, while also being the sites of geographic wonders that help us to better understand the past and future of our Earth. It is also important, however, to remember that American ownership of this land means it was stolen from native people who likely knew how best to take care of it. As the American government continues to ignore and threaten the national parks, we must remember the importance of this land and do our best to protect it as best we can.